We've all been there, right? You've had this brilliant idea for a setup, maybe a home theater or a big presentation, but you need to get an HDMI signal all the way across the room.
And physics just says no.
Exactly. The standard copper HDMI cable, it gives up after about 15 feet. You start getting those awful sparkles, or worse, just a black screen.
It's the classic bandwidth versus distance problem. And, people usually look at fiber optics or really expensive active cables, but NTI is doing something different here with their ST-C64K18GB-R-230C extender.
Right, they're using standard Ethernet cable, which is, it's so much easier to pull through a wall than a fat HDMI connector.
Way easier. But this is where it gets interesting. Usually when you convert a signal to run over something like CAT6, you expect compression. You assume you're losing something.
We're trading quality for distance. That's the usual deal. But they claim this thing keeps the full 18 gigabit per second pipe completely intact.
That is the whole point.
Yeah,
this isn't just about getting a picture from point A to point B. It's about maintaining the spec. We're talking Ultra HD 4K at 60 hertz with 4.4.4 chroma.
Okay, so for anyone listening, that 4.4.4 part means it's not throwing away color data to save bandwidth.
Exactly. If you need super sharp text, like for medical imaging or high-end digital signs, that lack of compression is it's non-negotiable.
Got it. And that feeds into their other big claim, right? Zero latency.
Because it's not having to compress the data and then uncompress it on the other side. There's no processing delay.
Which, for a movie, who cares about a few milliseconds? But if you're gaming or running a live presentation with a mouse on screen...
Oh, it's a deal breaker. Even a tiny delay feels wrong. It completely disconnects you.
Okay, so we have perfect quality, zero lag. How far can it go?
The base system, so one transmitter and one receiver, gets you 230 feet. That's about 70 meters. That alone covers most houses.
But not, say, an airport terminal or a university campus. And that's where this cascade feature comes in, which I think is the real aha moment.
This is the magic trick.
Yeah.
You aren't limited to just one transmitter and one receiver. You can actually daisy chain the receivers.
Wait, so you just plug the output of one receiver into the input of the next one?
You can link up to 10 of them in a chain.
So, hang on. If each one gives you 230 feet, you're talking 2,300 feet of total distance. That's almost half a mile.
On standard C cable, yes. A 4K, 60 hertz uncompressed signal over nearly half a mile of copper.
And you're not just extending the line, right? Each one of those receivers in the chain has an HDMI out.
Right, so it's a point-to-many setup.
Yeah.
One source can drive 10 different screens all in a line, each showing the exact same uncompressed content. Think of a long concourse in a convention center.
That's incredible. That saves a fortune on Video Matrix hardware.
It simplifies the whole setup. And they've included all the, the practical stuff you'd need too. It handles all the big audio formats, Dolby, DTS, and there's a dedicated optical audio port on the receiver.
Which is perfect for connecting to a local soundbar or AV system at the display. What about remote control?
It has bidirectional IR. So you can hide your cable box or Blu-ray player in a closet 200 feet away, point your normal remote at the TV, and the signal travels all the way back. It just works.
It makes the tech invisible to the user. And for a price point around, what, $130? That's an insane value for what is basically industrial-grade performance.
It really is. It's taking professional capability and making it accessible with consumer-level cabling.
It does make you wonder, though. We're pushing the limits of copper here to get uncompressed 4K through it. But as we all start looking toward 8K, where the bandwidth requirements basically double, are we finally at the physical end of the road for copper wire?
That's the big question, isn't it? Will we find clever new ways to squeeze more data through, or is this sort of the last great achievement for copper before everything has to be fiber?
A fascinating thought. This might be the peak of twisted pair technology, keeping our current infrastructure relevant just a little while longer. Well, thanks for listening to this deep dive.